Hi everyone. In this lecture we're going to talk about multiplication of real numbers. So if A and B are any two mathematical quantities, then their product, well, we can just write that as the following. So A times B, you could put a little dot here, or I think I've shown you this before, that there's several other notations for this. You can put them in parentheses to mean multiplication, or you could do A times B in parentheses like this, or A in parentheses times B, right? And these can be expressions, so they might be more complicated than just A or B by themselves. They could be larger expressions. So just kind of keep in mind that all those notations, we're talking about multiplication. One thing we have to keep in mind is multiplication, when you take the product of two numbers that have the same sign, then you will end up with a positive, right? So if you do a positive times a positive, you'll get positive, right? So coming down here and looking at the right here are the possibilities. So positive times positive is positive, okay? And another situation that you can have the same signs as a negative times a negative, so that would be a positive. Okay, and the product of two numbers with different signs, well, then that'll be negative, right? So anytime you have a negative times a positive, or a positive times a negative. So positive times a negative will give you a negative. Negative times positive will give you a negative. Okay, so as long as the signs are the same, you'll get positive, or both. So either both positive or both negative will give you positive. But if they differ, then you're going to result in a negative, right? So just some quick examples here. So 6 times negative 9, you'll get negative 54. Right, negative 7 times 5, right? They're different signs, so we're going to get a negative again, but then it'll be 7 times 5 is 35. Negative 8 times negative 4, we're going to get a positive, 8 times 4 being 32. Right. You could just write it without the positive there. That's fine. Negative 4 times negative 6, again, negative will give us a positive. 4 times 6 is 24. And 0 times negative 8. Well, 0 times any number is going to give you 0. Okay, and 0, it doesn't really have a sign, but yeah. Okay, so even if you put a negative in front of it, it's the same as 0. Okay, because remember that 0 doesn't have a sign, because the distinction, when you say positive, you're talking about things that are greater than 0, and things are negative when they are less than 0. So if they are 0, well, then they're neither positive nor negative. It just has no sign. More generally, if we kind of continue this idea, the product of an even number of negative numbers, well, then that will be positive. Okay, so if you have an even number of negatives, that'll be positive, right? And if you have an odd number of negatives, well, then that'll be negative. Okay, so here's an example of what we're talking about. So looking at this, how many of these are negatives? We're taking a bunch of products here. So we have 1, 2, 3. We have 3 negatives, right? So we have an odd number of negatives. So the answer is negative. Okay, so we know that the sign can be determined this way, and then now you just have to take the product of these things. So 2 times 4 is 8, and 3 times 5 is 15. 8 times 15, so this is 120. If you encounter fractions, multiplication is actually not too complicated in this situation. It's going to be more complicated when you have to add and subtract fractions, but when you're just multiplying them, the rules are just simply multiply the numerators and multiply the denominators separately. So we can think of this as, you know what, I'm just going to rewrite this. I'm going to bring this negative up to the top. Okay, you could bring it to the bottom as well, it could be either or. Okay, I'm just doing this so the multiplication is a little bit more clear. So see that this is going to be like this. Okay, and now we'll just multiply the numerator. So negative 3 times 5 over 4 times 7. So you have negative 15 over 4 times 7 is 28. Okay, and then in this situation, we have negative 6 times 1/2, and you can think of this as this negative 6, we can think of that as negative 6 over 1, so we have a denominator of 1 there, and we're just going to multiply by 1/2. So now multiplying the numerators, we have negative 6 times 1 over 1 times 2, so you have negative 6 over 2. And you could simplify that. This is just, this can reduce, and you could just write this as negative 3. Right? Because if I divide that in half. And then continuing this, so look at this notation, negative 2/3 times negative 5 over 9. Notice that that is not subtraction. If you're doing a subtraction here, then we wouldn't have had this parenthesis here. Okay, so just kind of continuing our process here. So I'm just going to rewrite that as negative 2 over 3, and then this one as negative 5 over 9. And now we'll do this product. So negative 2 times negative 5 will be positive 10, and then 3 times 9 is 27. Now using these properties, we can kind of we can generalize things a little bit more, and we can apply the distributive or associative properties to kind of simplify more complicated expressions. These are different things, right? So the distributive property, what that essentially is you let's say you're going to multiply negative 3 by this expression. We're going to distribute that in by multiplying the negative 3 by each of the terms inside that expression. Okay, the associative property just essentially is allowing you to move parentheses around. Like if you had an expression that looked like this, a times b and then times c, it'd be the same thing as a times b times c. Okay, that's when you could use the associative property. A lot of times you use that without thinking about it. Okay, the distributive property is definitely the much more important one that you will need to be careful of. Okay, so a situation like this one, you absolutely have to make sure that when you're doing this distributive property, you're going to multiply both of these terms by this negative 3. So here we would do negative 3 times the 2x, and then we will do plus negative 3 times the 5 here. So if you want to, make sure you don't make a mistake, it's a good idea to maybe just put parentheses around everything that you're going to multiply by, and then maybe get rid of them, which is kind of what you're doing with the associative property in a way. Okay, so then the negative 3 times this expression, you would just do negative 6x. Okay, because that's negative 3 times 2, you'd have a negative 6, and then the x just gets carried along, and then negative 3 times 5, that is going to be negative 15. Okay, so this is the result after expanding this expression here. So continuing, if we had this negative 1/3 times this expression, well, now we're just going to distribute this in and multiply both of these terms by negative 1/3. So this will be negative 1/3 times the 2x, and then we'll do minus negative 1/3 times the 9. Okay, so you have to be very, very careful that this negative will get carried along, and then I'm still going to have to multiply by that negative 1/3. It's very easy to drop that sign, so it's a very good idea to maybe put parentheses around all these things like I said before. And here you can kind of think of this, well, I have a fraction times something, and I can think of this this 2x as a fraction. You can always think of it as itself over 1, and then the 9, you could do the same thing as 9 over 1. Okay, so you know what, maybe I'll write that separately. So we'll have negative 1/3 times the 2x over 1. I'll just leave this alone. Minus 1/3 times the 9 over 1. Okay, and then now simplifying this, we're going to multiply numerators and denominators separately. So we'll have minus 2x over 3, and then minus, this is negative 9 over 3. Okay, and we could do a little bit of simplification here. So this is negative 2x over 3, or you could think of it as negative 2/3 x, that's fine. And then the minus, and then minus 9 over 3 becomes minus 3, and this minus minus is actually going to make it a plus now. So you could think of this as minus 2x over 3 plus 3. Or you could read this as negative 2/3 x plus 3. That's another way to write it, and it's still the same. Okay, you could write it like that too. That's still acceptable. Okay, well, what about this expression here? So we have -5 times this, and then we're going to subtract 10. So first, thinking back to our PEMDAS, so we have, we'll simplify what's in parentheses. It's already simplified. I can't do anything with this anymore. And then there's no exponents, then multiplication, so we'll do that first, right? So we're going to distribute this -5 in. So we'll have -5 times -3x, and then minus the -5 times 3, okay? You could also think of that as a -3, but then you'd have to have a plus here, okay? But I'm just trying to make it as simple as possible, just carry things along and then distribute only the one thing with the sign here. And then we will subtract the 10, okay? So what do we have here? So then -5 times -3 is +15. They have the same signs, both negative, so that gives us positive. And then negative will give us another +15, and then -10. And then simplifying this, so the 15x gets carried along, but then 15 minus 10 is 5. +5, right? Okay. Okay, so now let's say that we have expressions with variables in them, and we want to evaluate what those expressions are when you have values for those specific variables. So for example, let's say I have this expression, 5x minus y. Can you evaluate this expression when x is -2 and when y is -4? So all that means is you're just going to plug in those values for those variables. So we'll have 5 times the -2. Okay, so this x is going to become the -2, and then this y, so minus, you know what, maybe I'll switch to a different color so this is a little bit more clear. Okay, minus -4. Okay, so the y is in red, and the x here is in blue. Okay, and then once you get to this point, now you can just simplify it as normal. So this will be 5 times -2 is -10, because different signs, and then minus minus will be +4, and now -10 plus 4 is -6. Okay. Similarly over here, this expression is x cubed minus x squared. So if I'm going to substitute this x and this y value, well, there's no y value to substitute, so I'm only going to be substituting in that -2. So we'll do -2 to the third power, and then minus -2 squared, right? So we're just substituting x into those two spots, and now you simplify. So -2 cubed, that's the same thing as -2 times -2 times -2, and then -2 squared is -2 times -2, right? So here we have 3 negatives, it's an odd number, right? So that's going to be a negative, and then 2 times 2 times 2 is 8, and then here we have negative, 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 which becomes negative, and 2 times 2 is 4. So -8 minus 4 will be -12 then. If you ever encounter an equation, you could ask if a certain value or values for the variables involved result in an actual true statement or a solution, right? So right here, determine whether x equals -3 is actually a solution to this equation. So what we're just doing there is we're just verifying whether or not we're going to get a true statement here. Okay, we'll talk about this a little bit more in general later on when we're talking about linear equations, and this would be something in the solution set to that. So later on, I'll actually give you these equations, and you'll actually try to solve the x value or values. Maybe there'll be more than one in certain situations, but in this one, all we're doing is verifying. So determining, let's just plug in -3 and see what happens. So -7 times -3 plus 2 equals 23. And then negative will be positive 21. And then now on the left we have 23 equals 23. So that's true, right? So we have 23 equals 23, so that means that this really is a solution. Okay. Determine whether negative 10 is a solution to this. So there we're talking about x equals negative 10. So what happens now if we plug in negative 10 for this one? We will have negative 30 plus 4, and that's negative 26 equals negative 26. And that's also true, right? So yes, this is also a solution. Okay. Something that would not be a solution, let's say that you asked to determine whether x equals 0 is a solution, right? If you plugged in 0 here, then you get 0 plus 4. And 4 is definitely not equal to 26, so that would not be true. So x equals 0 would not be a solution, okay? Something's only going to be a solution if you plug it into the equation and you actually get this sort of trivial true statement at the very end. One common mistake that you can make when doing exponents is you just have to be very careful when you're identifying the base of an exponential expression. Okay, so if you look at this right here, negative 3 in parentheses squared, well, that translates to negative 3 times negative 3. And I'm writing that out very carefully in parentheses. Okay, and that would be negative 3 times negative 3 is going to be positive 9. Right? But over here, if you look at this, the way that this is written, the base here, negative 3 squared, you see that there's no parentheses around the negative 3. So what this is actually telling me is I'm going to do negative, and then here the base is actually just a 3. So I'm going to do 3 times 3. Okay, that negative just gets carried along, but it's not part of the base like it was over here. So then this would be just negative 9. Okay, that's another thing. If you're ever using a calculator and you want to plug these things in, you have to be very careful of how you're actually doing that. Okay, and this is one situation where that can happen, and you can end up with the wrong sign. Okay, so in general, kind of summing up what we were just saying, if you said negative a squared, well, that's the same thing as negative a times negative a. Okay, which would actually result, like if you simplify this, I mean, negative times negative is going to be a positive a squared, right? So that would actually be the same thing as this. But this expression here, when you say negative a squared, that is negative a times a. Okay, so notice you will get a negative in that situation. So just to get some practice, let's just evaluate a bunch of these. So negative 2 cubed, right? That's going to be negative 2 times negative 2 times negative 2. So negative, 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 that's 3 negatives, that's odd. So we'll get a negative, and then 2 times 2 times 2 is 8. So negative 8, okay. Negative 2 cubed, this is negative 2 times 2 times 2, okay. And that is also going to be negative 8, actually. Okay, so notice in this situation you might say, well, the parentheses don't really matter there, but they do in general. Okay, this is just a situation where it just happened to not matter, but in general you have to be very careful when you're doing this. Okay, negative 1 squared, this is negative 1 times negative 1, which is positive 1. But then this one, negative 1 squared, this would be negative 1 times 1, which is negative 1. Okay, so notice the parentheses here do matter. Okay, you got to be very careful with this. You might be able to guess the general situation when it is and is not going to actually matter, but don't have to worry about that really. Just be careful. So this will be negative 5 times negative 5. Here we are in parentheses, so I'm going to write that out. Negative times negative will be positive 25. Okay, this one, negative 4 times negative 4 is positive 16, or just 16. This one is negative 4 times 4, but that's going to give us negative 16. Okay, and then this one, negative 3 in parentheses cubed would be negative 3 times negative 3 times negative 3. So we have 3 negatives there, so that's a negative, odd number of negatives, right? And then 3 cubed, 3 times 3 times 3, 3 times 3 is 9, and then times 3 is 27, so negative 27. Okay, and then here, negative 3 times 3 times 3 is negative 27. And then this one is negative 5 squared, which is negative 5 times 5. Okay, negative 25. So to kind of give us a quick review of multiplying fractions again, remember that when you're multiplying fractions, you'll multiply numerators, and you multiply the denominators, but you're going to do these separately. Okay, so again, if I had 3/4 times 7/12, then you'd have 3 times 7 over 4 times 12. So you have 21 over 48. Okay, which you could reduce this, but I mean, we're just getting used to just doing this process, so let's just leave that as is. This one, we could write this as 7 over 1 times 1 over 6, so then you have 7 over 6, and then 2/5 squared, this is the same as 2/5 times 2/5, so now this will be 4 over 25. All right, now let's move on to division of real numbers. So if you are going to divide these things, what are the rules that we're going to follow in this situation? Well, let's first just talk about the notations that we're going to use. So, I mean, when you're dividing, we'll use A divided by B. You could use the division symbol like this, and I think we talked about this before. You could also write it as A over B as a fraction like that, or you could write it as A times 1 over B. Okay, you could write it like that too. You could also write it as 1 over B times A. Okay. But most likely you probably just use these first three situations. So let's divide the following. One thing to keep in mind before we do these ones, the sign conventions are very similar to what they were with multiplication. So if the signs are the same, if you have positive over positive, then you're going to result in a positive. Okay, if you had a negative over a negative, that would also result in a positive. So kind of the same thing again. If you have an even number of negatives, you're going to get a positive. If you have an odd number of negatives, then you're going to get a negative. So negative over positive will be negative. Positive over negative will be negative. Right? So just kind of keep that in mind. So let's just do 4 of these where you can see each of these cases, but they're just a little bit different. So 6 over 2, this is just 6 divided by 2, which is 3. Negative 6 over 2, well, this would be negative 3. Okay, 6 over negative 2, well, we're getting a negative, and then 6 over 2 is 3, so negative 3 again. And negative 6 over negative 2, we're going to get a positive, and 6 over 2 is 3. Also, I mentioned this before, when you're dividing things, and 0 is involved, you have to be very careful. So if B was any real number, as long as it's not 0, if you ever have 0 divided by some real number, that's always going to give you 0. Okay? But if you ever have a real number like A and you're trying to divide by 0, then that's undefined. Okay? We're not going to allow this. Right? So you're never allowed to divide by 0. But 0 divided by anything is always 0. Okay, so let's say, just really quickly, 0 divided by 6, well, that's just 0. I mean, one way to kind of think about that, you're taking 0 and you're trying to divide it, okay, but you already have nothing, so you're going to get nothing if you divide it up, right? And negative 2 divided by 0, well, that's undefined. Now, if you have to do division with fractions, there's a little neat trick that you can do here to make this a lot simpler. So if you had A over B divided by C over D, you can actually just convert this into a multiplication problem. All you have to do is just do A over B, and then you're going to multiply by the reciprocal of this. You're just going to swap the D and the C. So you have times D over C. Okay? And then you'll just have A times D over B times C, because we already know how to do this, right? Multiply the numerators and multiply the denominators. Okay, so just kind of remember that you're gonna flip the C over D and turn it into a multiplication problem. So let's just do a few examples together. So if you have 4 over 15 divided by 12 over 10, then we'll just write that as 4 over 15 times 10 over 12. And then now we could just do this multiplication. So 4 times 10 over 15 times 12. Okay. Now, you could do this multiplication out, but we could also reduce this before we do the multiplication. So, so just kind of to give you an idea of doing this reduction, like notice 4 goes into 12, right? So we could do, we'll divide the 4 and the 12 by 4. So if I divide the top by 4, I get 1. And if I divide the 12 by 4, then I'll get 3. So right here I'm doing a reduce, right? I'm just trying to make the solution simpler. You could do 4 times 10 to get 40 and then 15 times 12, but instead of thinking about that, let's just do the reduction. And then 10 and 15, they both have a common factor of 5 in them, so you could reduce that, right? So if I divided both of these by 5, what would you get? So 10 divided by 5 is 2, and 15 divided by 5 is 3. Okay, now this is a lot simpler to multiply, right? 1 times 2 is 2, and 3 times 3 is 9, so you have 2 over 9. Now this one, 3 over 8 divided by 9, we can think of that as 3 over 8. Okay, and then the 9, if you want, before you do the flipping, you can write 9 as 9 over 1. And then now maybe it's a little bit simpler to see how you flip this, right? So now it's 3 over 8, and you're going to do multiply by the reciprocal, so 1 over 9. So then we get, well, you could write this as 3 over 72, but let's get used to doing some reduction. So notice 3 and 9 have common factors, right? So I could divide 3 and 9 both by 3, and I'll get the equivalent fraction. So I could divide 3 by 3 and get 1, and divide 9 by 3 and get 3. And then now I just have to do 1 times 1, which is 1, and 8 times 3, which is 24. And I get this nice reduced fraction. Okay. Continuing, so 2 over 7 divided by negative 1 over 2. Well, we'll just do the reciprocal of this, so then it'll be multiplied by 2 over negative 1. And now no real reduction here, but 2 times 2 is 4. 7 times negative 1 is negative 7. And when you have more complicated expressions, we can just kind of combine all these rules together that we've been talking about. So doing sort of our PEMDAS, right? We're going to simplify what's in these parentheses first. So we'll have 2 minus, okay, and then 3 minus 5 is negative 2. And then we'll still have that minus 8 over negative 5 minus 4 minus 5. Right, it'll be negative, and you just add these up, negative 14. And that divided by 4 over 7, we'll just carry that along. You could change that now to multiply by 7 over 4, but let's just carry it along so you can kind of see what simplifications I'm doing first. So really all we did here was you simplified the denominator, and we simplified what was in those parentheses right there. So simplifying what's in these parentheses, we have 2 minus, negative 2 minus 8 is negative 10, and still over minus 14, and divided by 4 over 7. 2 minus minus will make that a positive 10. Okay, and then this will be 12 over minus 14. And now let's convert this, right? So divided by will end up becoming multiply by 7 over 4. And here you could multiply numerators and denominators separately, but we can do a reduction here. Do you notice that the 12 and the 12 has a factor of 4, so I could divide both of these. Okay, so notice, you know what? I'll just rewrite it here, and I'll do the reduction, so you can, maybe it's a little easier to kind of do this separately. So if I divide 12 by 4, I'll get 3, and if I divide 4 by 4, I get 1. Okay, I got to do both numerator and denominator, and now 7 and 14 have common factor of 7, so I can divide both by 7. Divide the top by 7, I get 1. Divide the bottom by 7, I'll get negative 2. And then now do the multiplication. So 3 times 1 in the numerator, we have 3, and negative 2 times 1 in the denominator is negative 2. So this would be our reduced answer. So another thing that shows up quite often is percents or percentage, right? I mean, percent really all that just means is per 100, right? Per 100, or 1 part in every 100. Okay, so you can do these conversions, right? When you say 75%, that's the same thing as 75 per 100, so divided by 100. So 75 over 100, or 3/4. You can convert that into a decimal as well, and probably that's the easier of the two to do, because if you want to convert a percentage, all you have to do, like this 75% here, just write 75, and you have a decimal here. And if you're dividing by 100, all you have to do is move the decimal place over 2, and you'll get 0.75. So that's how you get that. Okay, like when you're dividing by 100, you just move the decimal over to the left by 2. Okay, and 0.25 is the same as 25%, because you could move the decimal the other way, right? 0.25 is the same thing as 25 over 100, or a quarter. So that's how to write it as a fraction, or 25%, right? 25%, if I move the decimal over 2, then I end up at 0.25. And if I were to give you this fraction, that you could think of that as a percentage as well, right? 1/5 is the same as 0.20, or that's the same as 20%, right? 20%, if I move the decimal to the left 2 places, I'd end up at 0.2, which is this, and that's the same as 1/5. Okay, so percentage, I mean, it comes up quite often, right, in everyday use, so we should get familiar with, how to use this and whatnot. So first example, like, what number is 25% of 40? Okay, so one way to kind of translate this is you really are going to do 2 things. So to translate this, first, let's just translate the 25%. So 25%, move the decimal over 2 spots, and you will get 0.25. Okay, and then when you say 25% of a number, really the of just gets translated into a multiplication. So you're going to do 0.25 times the number that you're interested in. Okay, which is really a quarter. This is the same thing as 1/4 times 40, or 40 over 4. Okay. Right, you could do the multiplication this way or this way. It doesn't matter. You don't need to do that conversion. Like, you could just do this multiplication, and yeah, that's it, right? So this will just give you 10. Okay. So what percent is 120 of 2,000? All right. Well, to do this, I mean, here we're just asking what percentage is 120 of the 2,000. Okay. In this situation, what you're looking for is 120 out of the 2,000 makes up what percentage. Okay. So if you do this division, what are we going to get? So if you divide these, we will get 0.06, okay, as an answer. And then to convert that into a percentage, well, here's the decimal representation. But 0.06, you want to move the decimal to the right to get the percentage, right? If you start with the percentage, right, the decimal would go here, and then you'd have 6 points, which is 6%. Okay, but if you start with the percentage, you want to move the decimal to the left instead, right? Because there you're dividing it by 100. Here we're essentially multiplying it by 100. That's why we're moving it to the right. So we get 6% there. Okay, what is so how about this one? So 16 is 50% of what number? Okay, so what is 50%? So 50% is really 50 over 100, right? Which is a half, or 0.5. Okay, and we don't know what the number is yet. We're trying to figure that out, so we'll just say x is this number. And if you're trying to figure out 16 is 50% of some number, then we're essentially trying to solve this equation here, right? You could also write it as 16 is a half x, okay? And now if you want to figure out what x is, well, what we could do is we could just multiply both sides of this equation by 2. And we'll have 32 equals x. Right? I mean, you're thinking about this again. You're saying 16 is half of what number? Right? That's another way you can read that. So that would be 32, right?